Okay, mathematicians, we're back now with section 3 of chapter 3, rate of change and slope. So previously we graphed ordered pairs in the coordinate plane, and now in this first video we're going to talk about how to use rate of change to solve problems, and then in the second video for this section we're going to actually find the slope of a line. So those are our two vocab words or phrases, rate of change and slope. So the rate of change is a ratio that describes on average how much one quantity changes with respect to a change in another quantity. Notice that rate of change is a ratio, and what it does is it compares a change in one quantity with respect to a change in another one. So if x is the independent variable and y is the dependent variable, then rate of change is just how much y changed divided by how much x changed. The rate of change of the dependent variable, the change in the dependent variable divided by the change in the independent variable. So we can use this table here to find the rate of change and then explain what it's talking about. So if you look at the table, the x and y values are labeled with what they mean. Now, we don't have the whole context of the problem, but we know that x is the number of computer games and y represents the total cost. We could find the rate of change. So we could find how much does y change with respect to how much does x change. And here's an important thing, and you could carry this through math through years all the way up through calculus. We still talk about this. To figure out what the units on your answer would be, look at the units that you're using for the problem. So if you do the change in y, it's going to be the change in dollars divided by the change in x, which is the change in games. So change in dollars divided by change in games would be dollars per game, would be the rate, or the units for the rate rather. Okay, so change in cost divided by the change in number of games. So you could pick any 2 points in the graph. We picked these two right here to calculate it. So you figure out from 78 to 156. If you want to figure out how much the difference is there, you subtract the two. You do the last one minus the first one to figure out how far apart they are. So 156 minus 78 divided by here, 4 minus 2 is going to give us 2. So 78 over 2, if you divide that out, that would be 39. So the rate of change means that the cost per game is $39, or the rate of change would be $39 per game is another way to say that. Okay, here's one for you to try. Go ahead and pause the video and hit play when you're ready. Okay, we're back. So you want to find the rate of change. You could pick any 2 numbers from the table that you want. Let's do those two. So I do 96 minus 48 over 6 minus 3. That's going to give you 48 over 3, which is 16. And that would be the rate of change in the area with respect to floor tiles. So the surface area, in other words, goes up by 16 inches squared for every additional floor tile you use. So 16 square inches of surface is tiled for each floor tile that is used. If you used the second 2 numbers, you would have done 144 minus 96 over 9 minus 6, which would give you 48 over 3, which also equals 16. And you could even use the first one and the last one. You could do 144 minus 48 over 9 minus 3, which would give you 96 over 6, which again is 16. Okay? So it doesn't matter which 2 you pick for the rate of change in this problem, you'll still get the same answer. Okay? All right, so far you've seen rates of change that are constant. Many real-world situations involve rates of change that are not constant. That's why before we could pick any 2 points we want, any 2 pairs of points we wanted from the table, because the rate of change always stayed the same. It was always, was it $39 per game or 16 square inches per floor tile? All right, so the graph shows the number of people who visited US theme parks in recent years. And notice it goes every 2 years, and from 2000 to 2002, it went up. 2002 to 2004, it still went up, but not by quite as much. And then from 04 to 06, it really went up. So find the rate of change for 2000 to 2002 and 2002 to 2004. So if I go from 2000 to 02, be careful here. You want to do the change in the dependent variable, which is attendance, that's on the y-axis, so to speak, divided by the change in the independent variable, or the x-axis, or the time. So you would do 324 minus 317 over 2002 minus 2000 gives you 7 over 2, or 3.5. But you have to be careful. It's not 3.5 people per year, okay? Because the numbers here don't represent just people, they represent attendance in millions. So over this 2-year period, attendance increased by 7 million for a rate of change of 3.5 million people per year. So the final answer is the rate of change is 3.5 million, I would add the word people in there, 3.5 million people per year. Okay, so from 2002 to 2004, you just do the same thing. Get these two numbers, subtract over these two numbers, and then you get half, or 0.5. So over that 2-year period, the attendance increased by 1 million. So the rate of change is 500,000 people per year. And notice in every case, the amount was going up. So our rate of change was positive. Cool. All right, so let's explain the meaning of the rate of change in each case. So for 2002, on average, 3.5 million more people went to the theme parks each year than the previous. And then from 2002 to 2004, on average, 500,000 people, 500,000 more people attended theme parks each year than the last. So how are the different rates of change shown in the graph? Well, there's a greater vertical change from 2000 to 2002 than for 2002 to 2004, and therefore that section is steeper. Okay, you can see because it went up more for that 2-year period than from 02 to 04, and then from 04 to 06 it went up even more, so that section is steeper. Okay, so refer to this graph without calculating, find the 2-year period that had the least rate of change, then calculate to verify your answer. Go ahead and pause the video and hit play when you're ready. All right, so which 2-year period had the least rate of change? Now just looking at the graph, that's gonna be the portion of the graph that goes up the least amount. So right here. Now the rate of change, you would do 325 minus 324 over 2004 minus 2002, which gives us 1 over 2, or 0.5 million people per year. So for that section, on average, 500,000 more people per year went to theme parks than the previous year. All right, so a rate of change is constant for a function when the rate of change is the same between any pair of points on the graph of a function. Linear functions have a constant rate of change. So what that would mean is if you picked different pairs of points and got a different answer, then that would not represent a linear function. Since linear functions are lines, they always go up at the same rate of change. So they're always going to have the same steepness, whether it's really steep, going up, going down, straight up and down, flat, doesn't matter what kind of lines. Now, if the rate of change is different, you might have a curve, you might have, up and down type stuff like this. Okay, so determine whether each function is linear, and let's figure out how we would know that. So in the first one, what you would do is just calculate the slope between consecutive pairs of points. So we did the first 2 points, 1 to 4, so it'd be -8 minus negative 6 divided by 4 minus 1. Now make sure you always do the bottom minus the top, bottom minus the top, and you do change in y over change in x. And you can see as we went down here, we went from negative 6 to negative 8, negative 8 to negative 10, negative 10 to negative 12, negative 12 to negative 14. In each case, when we figured it out, we got negative 2/3. Doesn't matter that it was negative, it's just notice that the rate of change is always negative 2/3 no matter which 2 points we pick. All right, so the rate of change is constant, so I know from this table that the function it represents is a linear function. This one, however, when you calculate the slopes, or the rate of change rather, from consecutive points, you get a rate of change of 1, then it jumps up to 2, then jumps back down to 1, then jumps back up to 2. So this rate of change is not constant, and so the function is not linear. All right, here's a couple for you to try. Go ahead and pause the video and hit play when you're ready. All right, so this first one here, if I go from 11 divided by negative 2 minus negative 3, that would give me 4 over 1, which is 4. Okay, now I will caution you, you have to go through the whole table to show that they're all the same. If you start going through the table and you get one that's different, you can just kind of stop, because once you get one that's different, you know it's not a linear function anymore because all the slopes aren't the same. The only thing you have to be careful of is, did you do your work correctly? Okay, so the next one we would go 19 minus 15 over negative 1 minus negative 2, which gives me 4 over 1, which is 4. And then 23 minus 19 over 1 minus negative 1. 4 over 2, which is 2. So notice that is different than the other one. So no, this one is not a linear function. So if we do the next one, here, you would do 1 minus negative 4 over 9 minus 12. So you get 5 over negative 3. And I will tell you, if you keep going down, I'm not going to go through all of them, but if you keep going down, you keep getting 5 over negative 3, 5 over negative 3, 5 over negative 3. So this one is yes. I just don't want to make the video take tremendously long. Okay, so 3A, no, because you had one of the rates of change was different than the other ones, so it does not represent a linear function. But 3B, yes, it does represent a linear function because all the rates of change are constant throughout the entire table. Okie dokie. All right, so that's it for this video where we talked about how to calculate rate of change. In the next one, we're going to talk about how to find slope. So we'll see you there.